Hello everyone. In this video, we will see how to count prime factors of a number, right? In the last video, we saw how to find prime factors of a number, right? In the first example. So this video, this program will be the same, but we'll just count a variable, count the factors only. Okay, so count will be a variable, and that will track the factors. Okay, it will increase in each iteration. This is what happens here. If you see the program, guys, this program starts from here. Enter a number and we're taking the input. Okay, so number of prime factors. Okay, so we will count here. So count prime factors is a function, and we need to go in on that function, guys. Okay, so count prime factors, and we will declare a variable, and it starts, it has a value 0 in the beginning, right? So now we have a while loop, and what does this while loop do? Count the number of times 2 divides n. Okay, so how many numbers 2 divides n? Whatever number you provide, like 16, 12. So we need to find how many numbers, how many times 2 can divide that number, right? Okay, so if we try to visualize, guys, first iteration. Okay, so I just wrote n and 12 at the same. Okay, so your eyes may confuse, guys, don't be confused. Okay, so just uh, it just to remind you that it's n. Okay, so 12 modulus 2 is 0, we know that. So count plus 1. So this line, count plus plus is, count equals count plus 1. So 0 plus 1 would be 1, right? So now we will divide this. N equals to n divided by 2. Okay, so n divided by 2 means 12 divided by 2 is 6. So 6 is stored in this n as well. Okay, so now we have 6. In the second iteration, it's true, 6 modulus 2. N is 6, 6 modulus 2 is true, right? So we will, in this, here we have counts value is 1. In the previous iteration, counts value was 1. Okay, so counts value was 1. So 1 plus 1 is 2. Okay, so now what we will do, we will divide 6, this number 6 divided by 2 is 3, right? So here, now 3 modulus 2 cannot be 0, right? So this is why it terminates from here. So now you can count odd prime factors. Okay, so let's say how many, if any odd prime factors. So 3 I into I, 3 into 3, 9. So 9 is not less than or equal to 3, guys. Okay, so 9 is far beyond, so it will be false. So we can jump this for loop. We don't need to enter into this loop, and we have 3 already. We have 3, right? So our n's value is 3 after the while loop. So now we have a if statement. If n greater than 2, okay, so 3 is greater than 2, it's right. So we will count one more time, right? We will add one more, one more with count. You see here, count would be plus plus. Count is plus plus. Okay, so that means our previous count was 2, right? Our previous count was 2 here. So now we're getting one more. It will be 3, and return count. So count will be returned, guys. It will make 3, right? So these were the program, guys. It is like the first program was almost like this, but in this program we're just taking the count only, nothing else. Okay, guys, our next program is to find sum of prime factors. Okay, so we will just uh, take a number as input, and we will see which are the prime factors that can divide this number, right? And then we'll add the factors. Okay, so we'll get the sum of the factors. This is the uh, aim of this program. So we start from the main function always, guys, right? So these are these lines are for taking input, and printf sum of prime factors, right? And now we'll go to this sum of prime factors function, and let's see how this program operates. We have a let's say we are providing whatever number, 12, 16, whatever. Okay, so let's visualize this one, guys. We are providing 12 here as well. Okay, and we have another example with 27 too. So if you see here, sum is 0 in the beginning. Okay, so and then we have a while loop. So let's see what's in this while loop. N modulus 2. Okay, so let's say 12 modulus 2 is 0. It's true, right? So we will enter into this loop. We'll enter into this loop, and now, first of all, sum will be, sum will be, sum plus 2, right? So if you see here, sum plus 2. So uh, so that means 2 is a factor, guys. 2 is a factor that can divide that number, and we are just taking preparation to add 2, right? So you know we will add all the 2's, how many numbers uh, it can divide that number. Like if you get 12 here, 12 modulus 2, so we will get 6 in this time, right? So let's see, we will consider the second iteration as well, all the iterations, right? So sum equal to sum plus 2, so that means sum is 0, 0 plus 2 is 2, right? So and then n will be divided by 2, and value would be stored in the n again. So it will finally we will get 6. 12 divided by 2 is 6, right? So now we are getting the second iteration, guys. Second iteration, 6 modulus 2, because our previous n was 6, right? So now it's true, then we will come here. So our previous sum was 2, right? In the previous iteration we had 2. 2 plus 2 equals 4, right? So now n will be divided again. So 6 divided by 2 is 3. So now we can't you know divide this anymore, okay? Because 2 modulus 3 is not 0, so we will terminate from this loop, okay? So now some odd prime factors. So as we've seen before, we can't enter into this loop, and you know and we have a if statement. If n greater than 2, okay, so sum will be sum plus n, right? So here, if you see here, sum plus n, okay, so sum was 4. 4 plus n means 3, so 4 plus 3 would be 7, right? So if you provide here 12, you see sum of prime factors is 7, right? So after everything, you know we will come here again, so and this will be printed. So we just watching the examples with 12 only, so let's just get some variation, right? So let's do the same thing for 27. So here we have 27 as n, guys, okay? So sum was 0, first iteration. 27 modulus 2, it can't divide 27 evenly, right? 2 can't divide 27 evenly, so we will not this for loop, we will not do anything in this while loop, okay? So now we're going to this for loop, okay? So for loop starts from 3, guys, and 3 into 3, that means 3 into 3, 9. So 9 is less than or equal to 27, right? It's true. So we'll enter into this loop, and we have a while loop here, okay? So in this first iteration, n modulus 3, right? So let's see, I'm going to show you here, guys. See here. So we just, this condition is true, we came into this into here, right? So now while n modulus I, that means as 27 modulus 3, 0, this is true. So sum into sum equals to sum plus I, right? So what is sum? What is sum here, guys? Sum is 0, right? So 0 plus I means 3. So it would be 0 plus 3 equal to 3. So now 27 is divided by 3, and we get 9. So in the second iteration we will do the same thing, right? Here we will do 9 modulus 3 is 0, it's true, okay? So our previous sum was 3, and I is 3 as well. So 3 plus 3 equal to 6, and we're doing the same. We are doing we're dividing 9 by 3, so we get 3 here, right? So in the third iteration, 3 modulus 3 is 0, it's true, okay? So sum would be, previous sum was 6. 6 plus 3 equals 9. Okay. So now we will divide this. 3 divided by 3 would be 0, right? So we can't iterate anymore. Okay. So now we will check this if condition again. N greater than 2. Okay, so our n is 0, so it's not greater than 2, so this will not be considered here. So our final sum was this, right? Our final sum was this 9, right? And this is how program finishes, guys. This program finish, if we provide here 27, you get 9, right? So I hope you understood this, guys.